very recently, but I found myself wanting to go deeper into the scientific approach. So I studied painting in Belgrade, and I got a diploma which is equivalent to the Master of Fine Arts. And then after a few years of independent practice, I figured out that there are some projects that I would like to realize for which I needed some very specific skills and knowledge. And I found a master's program which is called Art Science, and it's an Art Science Interfaculty, a department in The Hague in the Netherlands, which is situated between the Academy of Fine Arts and the Conservatory. And I graduated last year. My diploma now is Master of Music. Just to give you, before we jumpstart into my work, I will be presenting my work through the prism of the topic here behind me. So I will be talking about my works and topics that interest me and the methodologies that I use. But before we go there, I would just like to give you a bit of introduction to art science. So this Department of Art Science is actually following a long tradition of experimentation in art. At the moment, it's celebrating its 27th anniversary. It's a pretty old department, and previously it was called Image and Sound. Basically, the premises of this department, led by some of the research of the experimental music in the 60s, namely Dick Rijmakers, the department wanted to basically kind of put down the boundaries which are given when you're doing art. So we should not presuppose that we are doing art, we should presuppose that we are investigating what is sound and what is image. So this department came to be in the Academy of Arts and also at the Conservatory. And so the first name of the department was Image and Sound. And like 10 years ago, about 10 years ago, they changed it to Art Science. And hello. So I'm talking about the Art Science department right now, but we're seeing today that there is such a rise in art science practices. During my studies at the interfaculty, I was very interested in what is art science, because we keep seeing it everywhere, but it never means the same thing. So basically, we have this heterogenic field of art science, heterogeneous, but we cannot really say what it is. There is a problem of kind of locating art science, but I wouldn't like to say locating because then we're kind of putting the boundary. But what I'm saying is that art science today could be scientists interested in the form of art to do the research or to present the research, or artists wanting to go into science. When artists go into science, what we're seeing basically is amateur scientists, because artists are not trained to be scientists. They're not speaking the same language. They're not interested in the same things. They're not there to make objective they're not there to find facts and say that something is objectively true or not. We as amateur scientists should be very focused on researching with some of the methodologies of science, but keeping our subjective view. Never ever forgetting that there is this person who has a kind of an aim to make art piece, who is observing through the lens of science. So it is actually, what I like to say is that very frequently it feels to me that art science is basically where people go to kill art. You know, you start with art and then you want to go into science and you end up basically killing with what you started. And I wouldn't like to kill art, because I find that there is an irreplaceable value to doing research through the artistic practice. So I was trying to figure out so now, next to the art science context, what I'm trying to do in my practice is find the ground on which art and science are based on. And this is kind of like a cybernetic or systemic approach. Because if we look in art, what we're trying to do there is, in a way, represent the unrepresentable, bring about the sublime, and bring about the catharsis, which you wouldn't have in science or you wouldn't have in the normal experiential daily life. So when you go into the systems and into the order of things, you start regressing. So how did this order came to be? There must be something that happened previously, something that led to this, and something led to this. And finally, after years of thinking about this, I realized that basically what I'm continuously looking at is the origin. I'm kind of trying to explain to myself the origin through the arts. So let's be more concrete. I see some wondering faces. I'm gonna talk about the work that I've made last year, which was part of my graduation project, Lexicon Liber Novus. And this is a view from the academy, the graduation festival. What I did is I was wondering about language. I think language is kind of an essential thing. And if we start looking, essential thing for this inquiry that I'm talking about. And if we just try to analyze this that we take for granted, and if we just try to analyze one word, it somehow, it seemed to me, and since now I feel like I have a bit more time, I'm just going to give you this short story. I was living in Paris because I did an exchange at the Beaux-Arts, and I was trying to learn French. And so I only studied French for a little bit. And then I found myself in Paris, and it was really, really stressful trying to learn the language so fast, especially French. But I found myself understanding what people were telling me without knowing the words. And to me, that was completely bizarre. Like this language that I'm just now trying to understand, I know the basics, and then somebody is explaining me something very specific, but I get the sense of it. So then I started thinking, is it because of the nonverbal cues? It is because of the intonation, the context of the entire sentence. And then I asked the person, but I don't know this word. And then they explained it to me, and it is exactly what I thought it was. So I was like, am I like dreaming the meaning of these words? Like, how do I know? And then I spent a lot of time on the dictionaries, the French dictionaries. And then I read about the word that I don't know. And then I find 25 other words that I don't know. And then I go look them up. And then there I find words that I don't know. And I just continuously never really understand what is said in French. And that got me thinking, what happens if we explain one word, and then we explain all the words that are used in the explanation, and we explained all of those, and we explain all of those, would we get the entire dictionary through a single word? Which implies, in order to explain one thing, you need to explain all. So I tried to do it. And I made an algorithm that starts from that does exactly that. I used a sentence from Jorge Luis Borges' two English poems. These poems that he wrote in 1939, the single poems that he wrote in English, and to which he protested to being translated, and those really nice poems about love and night. And I use the sentence "we talked and you have forgotten the words," and then I give the numbers to every single word. Basically, I now bring in a meta system of numbers because it is essentially an infinite set. Here, it's maybe clear. So the first word that appears gets number 1. The second word that appears, number 2. And then I explain the first word. And this is the dictionary explanation of it. And then the next number in the natural order is the new word that appears. So number 9, 10, 11, 12, and so forth. And once a word gets a number, it's always that number. So you is always a 4. We is always a 1. And what happened? So then I give definition for all of these. And I didn't explain the entire dictionary, but I ended up with 47,152 words in total. So in order for me to explain these 8 words, I needed to explain 47,144 other words, which meant that in print, that's 4,000 pages of the smallest possible print, like this. And oh, by the way, if something is unclear or you would like to ask, you don't have to wait for the end. You can just ask.
Yeah, this exercise depends on which dictionary you use also. If you use a very complete dictionary, maybe you will reach a very detailed dictionary. Maybe you will have a closure on that. You will have the whole dictionary.
Perhaps.
I mean, you will have a different.
Yeah, definitely.
Explosion. Yeah.
It makes a difference which dictionary you use. In this case, I used an Oxford English Dictionary, which you find on Mac systems, already embedded in the Mac systems. And I went for that one because actually I didn't get access to the entire dictionary. They didn't want to give it to me as a student, as an artist, or as an independent researcher. It is worth a lot of money because, you know, this is how we're building, you know, the computational linguistic systems. So it is a valuable set. But I have to say that perhaps if I looked really hard enough and long enough, I would have probably gotten the entire dictionary. But that would again be a problem for the process, the computational process. To generate all these words, the program was running 7 days nonstop. And I don't think I would have such a strong computer to hold everything, you know, in memory so that I can use the data. But this Oxford English Dictionary is pretty wide. It's about a quarter of the entire English dictionary, but this is very much because all the rest would be very specific, you know, discipline-wise words. So some words that appear here are really just random in terms of disciplines. A lot of things come up, but you don't have very specific phrases and words, you know, that you would have, for instance, I don't know, in archaeology, medicine. But I am very interested in what happens when you change the input, because this essentially represents a chaotic system. If one thing changes, if just in this speech, I don't know, I take out one letter, it's already a different word, meaning a different explanation, meaning everything different afterwards, right? So just one little rearrangement changes the entire structure. So now what I'm working on right now is next year I would like to launch how would I put it, lexicon on order, so that you can make your own lexicon. And you will see why I think that's kind of important. And also, I would like to investigate what happens when you have different inputs. What happens when you have just one word or 25 words as an initial input. So, I was interested in what happens in this structure. I am a painter after all, and for me to understand what's going on, I kind of need to have it drawn. I need to have it 2D. If I cannot draw it, if I cannot represent it, to me, I cannot understand it. I cannot think of it really. So I thought, okay, what happens in the lexicon if we take out the words and just look at the numbers and just follow the numbers? Let's just look at the order of things here. And in this drawing, I use the numbers as spatial orientation, right? They are positions in space. And this drawing represents the first 100 words, a bit more. And if you look just on the one side, because it's just essentially mirrored, this is number 1, the first position from the 0. So the axis is here 0, or the absolute 0, and this is 1, 2, 3, and so forth. And this is number 10. So I'm representing it by digits from 0 to 9, from 0 to 9, from 0 to 9. And you can just follow it very easily visually and say that this is 10 and this is 19, this is 20, this is where 30 begins, 40, 50, and so forth. And it doesn't matter what is the initial input in this case, because you always begin with number 1, right? And you will always have this ordering of numbers, so you will always get this kind of a structure, no matter what is the input. And I will explain the differentiation between the two later in the third diagram that I will show you.
But what makes it sometimes the line is like this and sometimes it's like this with a stair?
I don't have to explain because this is art.
Okay.
No, these are just my individual choices, right? So I use the paper which has triangles, right? And so because of these triangles, you get these specific kinds of ordering. And I decided, for me to be to read it more easily, I decided to connect the ones which represent a number, right? Here, this is still number 1, but since I didn't connect it, I am not reading it as 1, right? I'm reading 2. I'm reading 20, 21, 23, 24, 3, 25, and then these two, 13, 26, 1. You see? Does that answer the question? No?
Yeah, but is it
You were asking about this?
Yeah.
But that should explain it, right? It's just the last digit in the number. This represents the last digit in the number.
Okay.
But we also have a lot of data visualization today, right? And data visualization is meant for us to read something easily, to understand a large quantity of information quickly. And it's also meant to embed a lot of detail. But what we see usually when we're looking at graphs and statistic kind of charts is that the details are usually later to be shown in a more specific way, language or numbers. But I wanted to embed all of it. I wanted to think of a visualization method for what happens in the book that will take the entire process and also take the detail. So I was thinking, what I'm doing in the lexicon is essentially an infinite process, because it is only determined by the amount of words that we have in a dictionary. That's our limit. But the process is infinite. If we keep creating words, the process is gonna go forever. So as long as we can generate, this process continues. So I thought, how can I represent something which is essentially infinite? And then that's a very problematic thing. But in this case, since I'm trying to visualize it 2D, we have some forms that we recognize and know and kind of understand the dynamics, which could hold the infinity. So first I thought, and for this I will use the drawing board because I don't have those drawings on my computer now. I thought, okay, let's take everything that happens in the dictionary, because it is a loop. The dictionary stops at some point. It doesn't have anything more to explain. It's done. And everything inside is self-referential. Every word leads to every other word. So we could think of it as a perfect shape, a sphere. And this was one of my initial ideas. Could I represent the book with this form? And so I tried and I looked into different kinds of networks. And specifically I looked into the small world network. And this is the way we organize our airports, our trains, our transportation. This is also how we sometimes map social relationships, the 6-degree separation between everyone. Mm-hmm. In this small world network, every node is connected to every other node. This is true for the lexicon, right?
Is it?
Yeah. Then we get the Satan shop. Sorry.
But like, for example, the word, I don't know, like I'm thinking of an example, but the word, say like you get the word bear and the word, I don't know, triangle. They're not going to be connected directly, like node to node. They'll be connected through other nodes, sure.
Yeah.
But not, like in the small network, every node's connected by one connection to every other node. By one edge.
A small world network does not mean that everything is connected to everything, but that there is
That
a
you have
short
nodes.
route from any
Yeah.
word to any other word.
Yeah.
So
Yeah.
that you don't need to let's say follow hundreds of steps to go from bear to triangle.
It's like 7 handshakes around the world or
true.
something.
Yeah.
Oh, okay.
True. So that you don't have to build relationships directly to all these other nodes. You go from node to node. So this is a representation of node to node, but not all points which are in the network. So you don't have to go and build relationships with all of them. So when you're flying from Houston, you don't fly to all single little airports. You fly to the next biggest airport to go to the nearest airport. So you basically have nodes which are connected to the ones which are close to them. So you need nodes to be connected all to all, right? And this is systemically, this is a pretty good representation of what happens in the lexicon, but it's not really true because every single point acts as a node. Every single point, every single word generates so many and so many. It's not that kind of a structure, really. It didn't sound proper. But then I thought, okay, let's make it democratic, that all of them are equally important, and then all of them are there. And then I thought, okay, let's then build a circle and put all these words on a sphere, because here I don't have to visually, if we talk about how I'm drawing this, I don't have to draw what happens inside, because it's a perfect shape no matter how you look. This is on the outside. And then I thought, okay, let's say this is lexicon. And this can go infinitely because you can just expand. It will keep the same shape no matter how far you go. But the problem with that was if I would do it as the program is adding new words, what would happen is that now all of a sudden I have to add a new one and expand the circle, which would, okay, I don't have to draw this again, but adding a new one means that all of them need to move to make space.
Is that like the infinity hotel paradox?
I don't know about it.
Where every there's an infinite number of rooms and an infinite number of occupants, so when you add another guest, everyone has to move to the next room. And so
Well, yeah, in this case, yes.
you
But
said
this
no.
is not what happens there. So that's exactly that, and then I realized this is not a good representation. Because what happens is that once a word gets a number, it's always that number. It never changes. The order here, what would be the good? I mean, just to take the numbers, you know? And if one number changed here, changing everything else, no, that's not a good example. My point is that the positions are fixed. Once a number is given, that is that position in space. Because the word got the number because it appeared at that moment in time. It came at that point, so it got that number. And then it means it's only that point. It can't move. It appeared at that point in time, got that number. You can't move it. That point needs to stay.
There's a meaning.
Right.
It has a meaning now.
Yeah, so you change it a little bit, you will change the entire structure. So I can't move the nodes. So I have to represent the infinity where the points in it are fixed. So it's not a circle. But then I thought, okay, what other shape can hold infinity but keep the fixed points? Does anybody have an idea? Yes. Yes. And also
Line.
Spiral.
because these points don't have to move for this to expand, and it can go infinitely. So I tried it. And I built an Archimedean spiral where the propagation is equal everywhere. And the points are proportionally equally distanced. So here, starting from the resolution is really bad, but starting from number 1 and further, these points represent the numbers. And I just do the natural order. From 1, in this case, 49. And then I follow them. And I go, entirety of these positions, so the very positions are circular, not the entire structure. Because every single number, let's take 17, it's not only represented by 17. In this case, it is just a state that has previous state and has a future state. So every single number is in a way input-output. It has input, something leading to it, and it has output. So, because of this, I decided that following these numbers should also have a curvature. And the spirals that are outside are the numbers going from the number, and the spirals which are inside are leading to that number. So I can also visually read this easily, right? So I can say, you know, that 45 led to 44. Wait, this? Oh, it's so difficult. 1. Well, that was the mistake that I was looking for. I had a mistake in this drawing and I found it just now. But in principle, yeah, I started with that outsides are the ones going from the number and insides are leading to the number. And that I knew when I was drawing that I made a mistake somewhere. I just found. But yes, so basically I got fractals. I got spirals and spirals. And finally, the third diagram that I made was very rigid. Basically, I was just now focusing on the fact that every number represents a fixed point in space. And if that's so, I don't have to imagine all different kinds of forms. I can just take a 12 by 12 grid just to make those spaces. And then I filled that grid with numbers. This is how the lexicon goes. The first 8 words of the input, explanation of number 1, those words. And this is the explanation for the second word beginning here. And then when I did this, it became clear that there are 2 streams. The new words and the old words. New input, repetition. And this is in that rocket-like diagram, that was the differentiation between the empty and the black ones, right? The new and the old. And when I did this, it then became clear the values are really not important in this kind of case. I can just reduce it to binary. I can say in this case, there is 1, there is input, or there is 0. And then I did it visually like this. These are new things. These are old things. And when I got them back together to look at the structure, I got a black square.
But you didn't extend it further than the 144 because I would have been curious to see how it evolves up to 1,000 or 10,000.
No, because
I like the.
yeah, it would be interesting. I did draw it by hand. Honestly, I made
It's
a lot of them, and it's a lot of work.
You need to work with programmers. They could do it easily to generate this kind of bigger.
Still, I'm sure it would take a week of processing. Yeah, I'm curious
I
also,
don't think
but
so. I think that's a very simple algorithm to check whether something is already in the list or not. That would be easy to do.
yeah, I imagine. But then, would you actually gain any more knowledge from this image?
Maybe it might exhibit some patterns. I suspect at the very least that the number of novel words would diminish as you go down, that it would become more and more black, but maybe there are some patterns in there.
And what is that structure in which it would be represented?
Well, it could be like you did, starting with a square, you could make it into a rectangle that just continues.
Exactly my point. Any kind of representation I would make, it would be just me telling you what I see, not what really is.
No.
Because I would have to make a decision on how to order it, and this decision would not be truthful representation of the
It's
data.
always a choice of visual representation. There are infinite number of possible visual representations, but
Yeah.
one of them might give you some inspiration of what kind of pattern it gives. Yeah.
That's really what we see often in art science practice. The translation problem. That you take a set of data, you turn it into sound, you call it sonification, and you say this is that thing in sound, but it really never is. Because you translated it. You needed to say that this red color in sound needs to be that frequency. It's not per se given. That's the problem of translation that I was trying to avoid by looking only at the very abstract and very wide angle of this entire thing. So, but if you're not familiar with Malevich's black square, You are? Yes? Okay. Nothing, forget about it. He says, he says that basically we need to destroy. As an avant-garde artist, he says black image is the destruction. But it's not a bad thing. We need to destroy to create. So he made a black square in shape of a religious Orthodox Christian icon and presented it in first time ever exhibited in a corner of a gallery, which kind of simulates the altar, right? So he wanted to destroy the religious and any kind of image in art. And this was that radical. This is why this black square is so radical, because he wanted to destroy the image in art. And he did the white square on white background, black square on white background, and all those variations. But for me, this black square meant that this is actually the representation of all our knowledge. We never know anything more than this, because this is what I got from the lexicon. If I analyze it through binary and put all that data together, it's black, it's noise, this is all we know. So, I wanted to leave this work behind. I mean, it's already too much. I'm sure it's already too much for you too. And I wanted to use it. I thought, okay, I actually got a huge database where every word has a number. And I could use it. I could make the lexicon not only a work of art, but a tool. So I don't have to translate and decide any further. The lexicon can decide and translate for me. So the second part of the installation is a piece where I started working on a project where I built an antenna to listen to Jupiter radio emissions. And I was building this antenna at the European Space Agency 2 summers ago with the aim of registering the radio signal on the ground. Just to give you a bit of input, the Jupiter, the gas planet, is acting like a radio pulsar, basically acting like a star, frequently on very regular patterns, emitting large broadband of frequencies. And one particular bandwidth of these frequencies is capable of penetrating our atmosphere. And it's only like 5,000 hertz in total, from 18.5 to 18.6 to 20.1 megahertz. That's the frequency on which you can hear Jupiter. And if you have old radio receivers with the AM, very lower ones, you could also hear it on your radio receivers if you're somewhere outside of the city and far from the electricity. So Jupiter noise was discovered in 1955 by radio astronomers who realized that every 8 hours there is an emission. And finally, first they thought it was an interference. They were in a desert, kind of a desert. So first they thought it was an interference, a plane, a thunder, because when you're listening on these frequencies, you actually hear thunders around the globe, because the atmosphere is acting as a mirror. So you can hear a storm in New Zealand. So they weren't sure what it was, but it was so regular that they connected the fact that Jupiter was, I don't know, at that point, I'm not sure, rising at 4 a.m. and that's the moment when they have emissions. They connected. We found out that Jupiter is emitting radio and we can hear it. And a fun fact, I got interested in Jupiter radio emissions because of a dream that I had. So I went, as a part of the art science course, we went to the European Space Agency, and I mentioned the dream to somebody, to the teacher of the course, Dmitry Gelfand, and he tells me, but that's, Katarina, actually true. You can do that. I'm like, what do you mean? And he tells me about the radio emissions of Jupiter, and I go and build the antenna and have to find it out.
You mean you had dreamt that Jupiter was emitting
I had a dream that our atmosphere was a huge mirror. Basically, like I dreamt that I went out of the house and I saw buildings and I saw huge Jupiter. And I knew in my dream that Jupiter was not in reality close, but that our atmosphere acted as a mirror, magnifying it. So behind Jupiter, I saw other planets, but I never thought of Jupiter before. So I went to the European Space Agency and I mentioned this, and then Dimitri says this. I'm like, but ta-da! I have to do it. And when I went to research it, it turns out that 20 megahertz is actually a wavelength of 12 meters. Frequencies or wavelengths of 12 meters are so big that they can go through walls, not to mention our soft bodies. So every time Jupiter is on the sky and you're outside, electrons coming directly from that planet are passing through your body.
Electrons or electromagnetic waves?
Electrons,
Electrons.
free-flowing electrons, which are, should I explain this also? Because I'm not too sure, but I could explain how the emissions are generated on Jupiter. But actually, yes, they are electrons, which are by a very strong field of Jupiter and also the satellites, namely Io. They're, the cosmic radiation pushes the electrons, pushes the magnetic field of the planet, and from the Io actually goes into the pole like aurora borealis. And there is a kind of, how do you call it, acceleration, which makes them escape and beam directly towards us. And you have three different types of emissions. What we are listening on the ground, what we can hear on the ground, are short bursts and long bursts. And they depend on the angle of entrance of these electrons. If it's a wide angle, then it's a long burst. And if it's a right angle, it's a short burst. And it sounds like popcorn.
You mean we hear the electromagnetic waves that are generated by the electrons entering the atmosphere?
We hear them when we amplify them.
Yeah.
Yes.
But it's not that we catch the electrons, we catch the effects of the electrons on the atmosphere.
Both, I would argue, but I'm not sure. I'm not a scientist. So then I thought, okay, that project that I wanted to build, which I'm not going to explain now, failed. I didn't build the installation that I wanted to make. But I still had the recordings and the antenna, but only the recordings that I've made weren't very good, because in the Netherlands it's actually pretty impossible to listen on the frequencies of cosmic observation, like the cosmic noise and these kinds of emissions, because it's very close to satellite communication and military frequencies, and it's only just 15,000 hertz available for amateurs. But it's also the storms that you can hear, the electricity, your computer, a mouse, everything is going to be picked up. So you really need to be somewhere secluded to get good recordings. So for my project, I didn't manage to get those recordings, but I got associated with the outreach group of NASA called Radio Jove. And these guys want to, their aim is to make it available for people to easily build these antennas and listen for themselves. And every person who has Radio Jove software and this antenna actually also acts as a server. So all these people with the same software around the globe can listen to each other's recordings. And only recently, a year ago, European Space Agency started realizing the potential of amateur radio astronomy. So they're now using the data of radio amateurs, trying to kind of map globally what happens with the radio emissions, because up till now we were using large arrays, specifically in Nancy in France, this huge 144 antennas on a field, I don't know, a few kilometers radius, and they've they want to see the propagation of these emissions, right? So they have these arrays, so they could also have a larger gain. But if they use the amateurs' data, they have the entire globe. So I used their recordings. I used a recording from New Mexico. And what I did, I analyzed the recording so that everything that you can hear, the entire spectrum, is in scale of the book. So when I sample the data, when I sample the amplitude of the signal, every value I get is in the scale of the book. And so in this case, I measured this amplitude, and it has a word associated folder. So I basically made software that generates poetry based on radio emissions from Jupiter, and of Jupiter telling us finally his secrets. And this generative poetry was, I decided it needs to go in black cube or black square. So the poetry, so this is how it looked on the installation.
It's black ink suspended in a liquid on which you then project light.
Yeah. Water, ink, and light. I have this short clip from, I was in, the sound really doesn't matter here. So I was invited this year to present this work at the Gallery Petrović in Ljubljana as part of their international conference and exhibition called Earth Without Humans, basically focusing on looking for extraterrestrial life and creating conditions for life in outer space. So they invited me to participate with this project, and I'm showing you the video from there because I don't have my own video documentation. So that you can see how it looks in space. This is an example of a poem. Well, thank you for coming, Anna.
Thank you for the talk. Like, can watch the end of it on the
Yeah, so the poems, as you can see, are not grammarly structured. It's just words kind of randomly being after one another. And I really liked it, because for us to generate meaning and to find meaning in this, we don't really have to have grammar. We just need to have words, just to give us an idea. And you yourself, as a spectator, you're gonna fill out the gaps. You will find meaning in this. So I kind of reversed the process. In the lexicon, I really wanted to say this is the meaning. And then it escapes. And I'm like, all of this is meaning. I want to have it. Then I realized we have it. I just need to give you associations, you're gonna do it. Because everybody has infinite potential for generating meaning and associating. And if we look at the beginnings of the linguistics, we will see that there is this random effect that we never know. How people connect the sign with the signified. We don't know how they connect it, because it is just a general convention that when I say a house, you know what it is, a house. But if I decide that house means something else for me, I needed to explain it for you. So all of us can connect words and find meanings separately. It's just the general consensus how we do it.
What makes it interesting for the poetry is that each word will evoke some meaning, but if one word follows another word, the first evoked meaning will influence the second evoked meaning, which will influence the third evoked meaning, and like that you build up some